Hey grade 12s, just going to do a quick video here with some of the solutions to the assignment you had on force of gravity, the universal law of gravitation. Questions 3 and 4 had to do with proportionalities, and I just wanted to make sure that you were aware of how to do questions that had proportions in them. Proportions are not that bad, except you can't use the numbers that are given, you have to use the factors that are given. So for instance, in question 3, it says we have a force of gravity between two things that is 36 newtons. So that's what the force of gravity between two objects currently is, 36 newtons. Then it says, well, what happens if the mass of one of the objects is doubled? Okay, well, let's deal with that one first. If one of the objects is doubled, remember that the force of gravity is directly proportional to the masses, which means that if the mass of one of them is doubled, one of these is doubled, which is going to make the force double. All right, so if we want to write that out, it would be Fg is now proportional to 2 m1, m2. All right, and there's a factor of 2 that's going to affect the force of gravity. The distance is also tripled between the two. Now, just dealing that by itself, because distance is an inverse proportion to the force of gravity. In fact, it's an inverse squared proportion. If I triple the distance, that means the force is going to become 1/9 of what it was. What that looks like in this proportion is I can say, well, this is now, instead of d, it's 3d squared. And if I take and simplify that a little bit further, we're going to get, and I'm going to actually take the numbers outside of the brackets here. We have a 2, and then we have our m1, m2. And on the bottom, when we have 3d inside the brackets and we square, both pieces get squared. So 3 squared is 9, and d squared is d squared. Okay? Now, what we see here is the original proportion, m1, m2 over d squared. What's different, what's new, is this factor of 2/9. We're doubling and we're dividing by 9. All right, so the original force was 36 newtons. We are now going to double that by multiplying by 2, and we're going to divide by multiplying by 9. And if we do that, we will get our answer of 8 newtons, right? 36 divided by 9 is 4. 4 times 2 is 8. So the new force of gravity, after we double the mass on one and triple the distance between them, it's going to take the force from 36 to 8, because we're going to double it first, which makes it 72, and then we're going to triple the distance, which means we're going to divide the force by 9. Okay, we can work it out this way. It works out nice and easy. All right, question 4 now. Question 4 has us on Earth, and it has the force of gravity on us being 600 newtons. All right, so there's a distance between us and the center of the Earth, the radius of the Earth. Now this question takes us to Mars and asks us, what does the force of gravity become on Mars between us and Mars if Mars' radius is 0.54 times that of Earth and its mass is 0.11 times that of Earth? And so again, we don't need the masses or the distance, the radiuses, we just need to know these factors that are changing. All right, so the distance is 0.54 times, the mass is 0.11 times. Here's again our proportionality statement. Fg is proportional, directly proportional to the masses, inversely proportional to the distance squared. So here I'm going to take the mass of Mars, the mass of the planet, and I'm going to multiply it by 0.11. Okay, it doesn't matter what the mass is, the factor is 0.11. All right, and I'm going to replace d with 0.54 d. All right, because again, that's how you would find the distance of Mars if we knew the distance of Earth, right? If we knew the radius of Earth and we knew that Mars's was 0.54 times that, we would do 0.54 times the radius of Earth, and now we're going to square it. So then to get this answer, what we're going to do is we're going to take the old Fg, which was 600 newtons, and we are going to multiply that by this factor of 0.11. And we're going to divide it by this factor of 0.54 squared. And if we punch that into our calculator, you will get 226 newtons, or as the answer in your book says, 230 newtons, and that is rounding to significant digits. All right, so again, it's all about the factors. How is the factor making the changes, right? If I change the mass by 0.11 times, that's going to change the 600 by 0.11. If I change the distance by 0.54, that is 0.54 squared that I'm going to have to divide by. Hope that makes sense. If not, you can shoot me another email and I'll be happy to answer it in a different way if I can. Have a great day. We'll see you soon.